Hello everyone, welcome to lesson 1 on the crash course on Python for data scientists, or more specifically geospatial data scientists. This is our very first step. Well, we have set the ground for this, so we have learned how to set up a Python environment. We have learned how to set up JupyterLab, which is the environment that we are going to use for our programming. And now that we have done the setup, we are going to take our actual first lesson. So if you haven't done those preparations, I strongly recommend you to start with those videos. I will try to add the link somewhere here to the video. So once you set up the environment, then come back here and let's get it started. By the end of this lesson, you will be able to understand what Python is in practice and how it runs instructions. So very basic introduction into Python. Use JupyterLab to write and run simple Python code. We had an introduction into JupyterLab, but now we actually start writing codes in it, and so you will get more comfortable working with this, with the interface. We will do some basic calculations, for example, printing results to the screen, and simple mathematical calculations. We will create and use variables to store data, and we will recognize different basic data types in Python. That's the agenda for today. Without further ado, let's get it started and do some coding. Okay, so we have our JupyterLab environment open, and we are ready to start our work. So as a reminder, we did already a reminder on how to write code in JupyterLab and how to set it up. If you haven't checked that out, please start with that video. But just as a quick reminder, we are going to create a new Jupyter notebook in which we will write our code, and we will create new cells. You will see shortly how that works. And remember, you will run, at least on Windows, with Shift Enter you can run the cell. If it's a markdown, you will see the formatted code, the formatted text. But if it's a code, Python code, then you will run the code, and if there's an output, that will be printed on your screen. So I will start with, I'm in the right folder already, so I will start by creating a new notebook file, and this is how we can do it. So it creates a new notebook file on my in my directory. So I will start by saving the file, so you can just click on this little disk icon up here, or just go with the shortcut Ctrl S. It will prompt you to enter a name for your file. So I'm going to name this Python lesson 1 or something like that. You can of course name it however you want. So I click on rename and save, and my file is saved. So as you can see, by default it creates you a new cell. So I'm going to start with Markdown. Remember to change it to Markdown from up here. So I will put a title, lesson 1 Python basics. And if you want to add more text to later remember what you have done in this lesson, you can just add the text here. Intro to be added later. So I will add some text here and upload it somewhere for you. But if you run it, then you will see the text will be formatted. But that's Markdown, and you can learn how Markdown works. There's a lot of great materials online, so you can see how it works. But what we want to do today is to start coding. So one of the first functions that you should learn is the print function. So it's a built-in function of Python that essentially prints out an output to your screen. So this output can be just a piece of text, like this is what we are going to do now as the first thing, but it can also be something, the result of your output or analysis. But we will get there later on. So I will start with a piece of text. So Python. So remember that whole text should be within the quotation mark, otherwise you're going to run into errors. and I press Shift Enter and I print something to my screen. So this is the output, and it's a nice thing of in JupyterLab you get the output right under your cell. So this is a simple text, but you could also do the same thing for different kinds of calculations. So to start, we will go with some simple math. So 2 plus 5, 6. So if you just run this, you will get 8 as the output. So this is a very simple calculation, but you probably can imagine that you can apply the same logic and just print out whatever the result is. So similarly, you can apply, you can do different kinds of mathematical calculations. So you can do subtracting, so 10 minus 4. So I will put them all in the same cell, not to make the screen too messy. You can also calculate, for example, you can do you can multiply two numbers. So I go with 5 times, and this time I go with a float. We are going to talk about data types, but basically having some decimals. So 5 times 4.4. You can also divide, do division between two numbers. For example, here I'm going to divide 8 by 4. And the next thing I'm going to show you here is powers. The 2 stars mean power, so I want to go with 2 to the power of 3. And this is how you would write that. So 2 double asterisk means power, so to the power of 3. So very simple math. Let's just run this, and you see the output printed. So I have a typo here, and it's good that I actually had a typo, so you get to see an error. So errors are very informative in Python, and over the time with newer Python versions, they have become more and more informative. So they're kind of your friends. What this is telling you essentially is that you have typed in a word, so you have a name error, and it's going to tell you that you have typed something here that was not recognized by Python. And it's not surprising because I have a typo in print, and you can also see from the color. So this was recognized by my environment, by JupyterLab, as a known function in Python, but this is not. So this would have given me a clue that I have a typo here. But yeah, this is an overview of an error. You are going to see more of these, and as I said, this will help you debug your code. So these are the output. The calculations are done, and the output, the result, is printed to the screen. So this is directly calculating something and printing to the screen. In JupyterLab, you could have also just done this without writing the print function. But remember, this works in JupyterLab. So if you have a script you're running and you want to explicitly print the output to the screen, then you should go with the print function. But in JupyterLab, at least, it works without printing necessarily. But what we very often do is that we do some kind of calculation, and this can be different things depending on what you're writing the code for. But you end up with some result, or sometimes it's not even your result, but it's a value you're going to use in your code. So it is common to go with variables. So even if you're going to just print it out in this case, we could have stored the variable, the number in this case, or any data type, under a variable, and then you can address to that variable. So you can reuse it many times without typing this every time. So I could have just stored the value of this under a variable, and then just reuse it. So creating variables in Python is very easy. So the thing you have to do is to just write down the name of the variable, and when choosing the name you have to be careful. So there are some rules governing the naming in Python. So for example, you cannot have a variable that is a number. Like the name cannot be a number or cannot start with a number. There are also some signs that are taken. For example, you cannot have a dash in your name. And there are names that are taken. For example, print in Python means something. It's the function that you just used. So if you use print to name your variable, then you're gonna get an error. Yeah, so how do we store value inside a variable. So the first thing you do is to give it a name. So I'm going to give a simple name. So I go with x, and the value for x is 5. I will create a second variable, and I'm going to give it another value. So the value for my y is 3. And then I'm going to create a third value, a third variable, and that's going to be called z or z. And for that, I'm going to multiply the two numbers. So instead of what we did earlier, like 5 times 3, I've stored them on the variable, so I can just conveniently use the value that I've already stored on the variable. So I will just go with x times y, and then I can just put the name here to get it to the screen. Because if I don't put anything, the code is run, but it's not printed. In order to get it printed to your screen in JupyterLab, you can just put the variable's name and run it like this. But to make sure that it works in whatever environment you are using right now, I'm going to just write a print statement. So I'm printing the z value which I just calculated and put it to the screen. So this is how variables work. And as I mentioned, it does not necessarily have to be a number. It can be other things. It can be numbers of different type. So it can be integer, it can be float, but also it doesn't have to be a number. It can be, for instance, a text. So I'm going to create a new variable now. So I will create a city name. And I'm going to call it, so I'm going to store name of a city under this variable. So I will go with the city Berlin. And as we know, Berlin is a city in the country Germany. So now this is stored on the variable. So I'm going to test this and print the value for my city. So if you run this, you will see the name of the city is printed out. It's just the value stored. So if you do the same thing for country, you're gonna have Germany on the screen. So there are a bunch of useful things you can do with the strings. For example, if you want to make a longer statement, putting the name of the country and the city and country in the same statement, you can, for example, go with city. So we will first print city, then I'm going to add a comma and a space. So remember, I'm passing this as a string. As I said, a string has to be within quotation marks to be recognized as a string. And then after that, I'm going to put add the country name. So this will just add, I have so many typos. Yeah, so country. Yes. So city plus comma space and then country. So if I run this, I will get Berlin in Germany. As you might guess, you can also replace this with another piece of text. You can say city, which is Berlin, is in Germany. To make it look nicer, I will put a space between Berlin and East. So yeah, so this is very simple. It may not make sense to do something like this right now, but later on, remember, a big motivation for many of us to use Python for coding is to automate our tasks. So if you're going to print something automatically to the screen in certain situations, then you should have this kind of code that automates the task for you. Just remember the text is the text in the code is called a string. It's a data type. So we can store words in variables the same way as we stored numbers. So you can store strings. And if you want to print it, you can join different pieces of a string with a plus sign, like just we did. What we just did. So you can also mix text and numbers. So I will go with a new example. So I have a number representing the population of a city. So I will just store it as, so the variable name I'm using is population. And let's imagine that the population of, I can quickly Google. So the population of Germany as of this moment is around 3.7 million. So I'm going to use that value and store it in my variable called population. So I will store it as a number. So 3,700,000 people live in Berlin according to data from 2024. So I'm going to then print something a bit more complex. So I'm going to say in my city, which was Berlin, and to make it look nice, I will put a space between this in and city. In city, Berlin, the population is. So next thing I'm going to do is to add the population information. And remember, we have stored this up here as a variable. So I'm just going to copy the name of the variable and add it here. In Berlin, the population is 3,700,000 people. So again, an example of how we can automate this kind of printouts on your screen. So I'm combining different texts using a plus sign, and I'm adding a number there. Remember that here I'm separating it by a comma in between. So I could also convert this to a text. So by using str, which is a data type. So I will convert my population to string, and I'm going to store it somewhere. So I will call it pop_string. So later I will remember that this is my population data as string. So if I just run this, the new variable is created. And if I check the value, if I run it, I get the same 3,700,000 people, with the difference that this time the output is actually within quotation marks. So this is telling you that Python, although this is a number to you, for Python this is a string. So you cannot now do the normal mathematical calculations with this. But what you can do is that, for example, you can combine it with the string. So if we go with something like this time, so because we have population as a text, we can just combine it with the text that we had earlier. So pop_str. So you can also do it this way. So the output looks the same, but gives you more flexibility when it comes to doing operations on the text. So I already showed you how conversion between different types work, but let's quickly look at different data types we have. So we already saw a string. It's basically a piece of text. We also have integers, that means whole numbers, so numbers that do not have decimals. So if the good thing about, one of the nice things in Python is that you do not need to explicitly say what kind of data type you are storing in the variable, because it can be recognized automatically. So Python sees that this does not have any quotation marks, so it's not a string. It doesn't have any decimals, so it's not a float, so it's an integer. So if I just check the type, and this is how you can check the type of the data stored in a variable, and if I just put the name of the variable, type population, it's going to tell me that it's an integer. if I had done this differently, if I had put decimals here, even if it was like this, so population 3,700,000.0, and if I run this again to redefine the population variable, and if I redo this, you can see that it became a float. So it was automatically recognized as a float. So if I test the same thing on this pop str, remember it's the population number that I converted to string. So if I check the type for this one, I'm going to get string, str, short for string. So it's a string data type stored under this variable. So as long as it makes sense, you can do a bit of conversions between different variables, the data types. So for example, a number can be converted to a string and then it's recognized as string. So you can do these conversions by just using the short name of the data type. So if I have a number that has decimals, so let's say I have the value pi number, which is 3.14 up to the 2 decimals. So this is going to be recognized as a float. But if I want to convert it to an integer, I can do that. Just remember that integers do not have decimals. So what happens is just it gets rid of decimals. So this is not a proper rounding of the number. We're going to later see how to round numbers. But for this will just cut the decimal part. So this is not the proper way of rounding numbers. But anyway, if it's converted to an integer and then print it, so I'm just doing everything in the same line of code. So this does the conversion, then I put the whole thing inside print to print it out to the screen. You can get the output as integer. So you can also test with type. You will see it's an integer, but I can already see that because this is just dropped. So it became an integer. So one way of rounding numbers, not the best way, but it just gets rid of the decimals for you. So you can do the same thing between different formats. So you can convert something from integer to float. So float of number 3 and if I test just print out this to the screen, you can see that it was converted to float and it just added a 0 as decimal, so it will be a float. Yeah, so these are examples of different conversions. We are gonna need them in different situations, but we will see them later. One thing about variables is that you can update the value of the variables at any time. So you don't have, in Python we don't have constant variables. In some programming languages you have constant variables that you cannot update. We don't have that in Python, so essentially any variable you have can be updated. So imagine that I had the variable called population. So imagine that I have gotten some new information about this variable, which was the population of Berlin. So I will just update it, assuming that, okay, I just heard that I was wrong and the population is 10,000 more than what I had thought. So you can just do this. So I'm just using the old value of population, adding 10,000 to it, and I'm storing it in the same. So essentially I'm overwriting the variable. Then I can just print something and say new population is, and then I will just add the population variable here. Remember there is a number here, so I cannot use the plus, but I put the comma and I add this to my print statement. So if you just run this, you will see that, yeah, you ended up with 10,000 more. And remember that we did the convert this at some point to a float. So that's why we have these decimals. If you want to get rid of that, remember that you can always convert your variable to integer using int, like that. So we can change variables by reassigning them. The line takes the old population here and adds 10,000 to it, and it stores it in the same variable. So you're essentially overwriting the value. So just be careful with that. In case that's not what you want, you could have just given a new variable here. For example, you call it population new. When it comes to naming variables, just be mindful of what names you use. It's very easy to be lazy and choose a name that does not make sense. So if this is important to you and you're going to use it later on, just give it a name that makes sense. So do not go with overly long names. That's wasteful, that takes a lot of time, it's confusing. Do not go with names that do not make sense. So this is very lazy to name this P, because if I look at this code a year from now, or if I share it with someone, P does not tell anything. So go with something that is a bit more descriptive. And if you have multiple words, for example, if this is the population of Berlin, so you can go either with, for example, underscores and adding more information. This is a good habit. Or if you want to avoid the underscore, you can just use a combination of lowercase and uppercase for naming. So this makes it a little bit more readable. So yeah, so not only there are restrictions with how you can name, there are also good coding practices, like how to choose names so their code is readable and looks nice, and also useful for later on, so you can read the code rather easily. So I will, now that we learned how to work with variables and do some basic calculations, let's start with some mini practical example. So I will go with the city of Berlin again. Then I have the area, and I'm going to store it in square kilometers. So remember naming. So I'm giving it a name that makes sense, and this is the area of Berlin in square kilometers. So 891.8. And the population, to be a bit more precise, is 3,769,000 as of this moment. So the next thing I'm going to do is to actually calculate something. So I'm going to calculate the population density for Berlin. So for calculating the density, you just divide the number you have, the population, by the area, which we have stored under area underscore km2 or square kilometer. So once I have my density calculated, I'm going to print this out to the screen. So I will write some text. So population density of, and then I put a space so it looks a bit nicer. Then I'm going to put a variable here, which is my city. So I can put it as a variable separated by comma, or like we learned before, you can just combine them by adding, because it's a string, so you can also go with the plus sign and put the city there. So the population of city is, and then I'm going to put my density calculation, so what we just calculated. So this is a good thing. So we have already done the calculation. It's stored in a variable. I just put the variable's name here, not the whole calculation formula. So it's much neater. A simple example of why this is actually useful. So density, and I'm going to write, okay, people per square kilometers. And of course I have a typo here, so population is written like that. So population density of Berlin, I will add a space here to make it nicer and rerun the code. The population density of Berlin is 4,226, with a bunch of decimals. If you want to make this look nicer, if you want to get rid of the decimals, as you remember, you could have just converted this to integer. So you can just write this is approximately like this, square kilometer. So this is an example of how you can use variables, do some basic coding. So now you can practice with this a little bit. I will also add some exercises in case you want to practice on your own. So this is the exercise you can do. So I will put it as a markdown code here. So make a variable named distance kilometer with any number. You can name it differently if you want. Convert it to meters by multiplying by 1000, and print it out together with some text that makes sense. So you can do this little practice and see what you get as the output.